Okay, so let's look at this polynomial right here. You may notice that there is a root at x equals 1 and x equals 2 here, because when you plug in 1 and 2, each of these factors goes to 0, so that means the whole thing becomes 0. But let's look at the function around these roots. Here, around the root at x equals 1, it sort of just pierces through, right? But at x equals 2, it sort of just drops by and then stays positive, right? Just like gives the x-axis a kiss. So what's going on? Why is it doing that? Well, if you look at the function here, you could see that there's something sticking out with the x equals 2 root, which is that it's squared right here. The factor is squared. So what does that mean? That we call that a double root because it sort of counts twice. Okay, so why does a double root look like this? Well, let's look at the single root first and see what's going on here. So if you zoom in really close, this will look just sort of like a line going through the x-axis, right? So why? Well, if you look at a really zoomed in picture of the graph around x equals 1, that basically means you're only considering really small values of f around there. So out of these factors, these two terms will be relatively large around x equals 1, right? So the only term that causes this function to become this small around there is this one, right? So obviously the function's going to look like this x minus 1 term. Or it'll look like a linear. It won't actually look exactly like x minus 1 because it'll be multiplied by some slope, which is determined by these two factors here. Okay, so now let's look at this. Let's zoom in really close. And now notice here that these two terms will be relatively large around x equals 2. So the term causing all the smallness in f is this middle term, x minus 2 squared. And x minus 2 squared is a parabola, so it looks like that. So the function will look like a parabola. Not exactly like x minus 2 because it's going to be multiplied by some slope caused by these terms here, which will be like, these will be like some finite number at 2, right? Okay. So now the question is, why does a parabola look like a U? And this is a little bit outside the scope of this video, I guess, but I'll quickly explain why. A parabola, let's say you just have a regular old parabola, right? And here I'm drawing it as a U, but this proof doesn't actually assume that a parabola is a U. So it has two roots here and here, and these are both single roots, right? So the leftmost root will look something like this if the parabola is one way, and then the other one has to go through the x-axis and it has to come from below because the function went below. So when it comes back up, it has to come from the bottom up. So now you see it looks sort of like this already. And then imagine shrinking the distance between these two roots. So you're shrinking the distance, and if you consider like taking it to the limit, so you shrink it all the way down to 0, then they'll just go like this. So that's sort of like a very wishy-washy reason or proof that a parabola will look like this around if it's like touching the x-axis like that. Okay, I think that's it for this video. Bye.